The universe continues to expand more and more, a phenomenon that has captivated scientists and astronomers for decades. In 1929, Edwin Hubble made a groundbreaking discovery that galaxies were moving away from us, proving that the universe was expanding. This revelation has had profound implications, suggesting that the universe was once much smaller, possibly originating from a singular point in the Big Bang. As we observe the cosmos, we are constantly reminded of its vastness and infinite potential. We are only beginning to understand the enormity of the universe, and each new discovery brings us closer to understanding our place within it. In 1929, scientists discovered that our bodies are composed of chemicals that originated in the cores of stars, which forever changed our understanding of life. The concept that we are made of stardust reveals the interconnectedness of all living things to the cosmos. By 1957, we realized that the sky was not just a beautiful sight but an integral part of the universe's vast and complex systems. The realization that everything, from the air we breathe to the molecules in our bodies, has origins in stellar processes makes us feel both connected to and minuscule in the grand scheme of the universe's existence. There is so much happening in the cosmos that, in most cases, we have no idea what is going on. The cosmos is so vast and complex that our understanding is limited to only a tiny fraction of what exists. Even with the most advanced telescopes, we are just scratching the surface of discovering the mysteries of space. We continuously wonder about the nature of our existence, the meaning of life, and the possibility of other civilizations. These fundamental questions drive scientific exploration and encourage us to search beyond our planet for answers to the ultimate questions of life and the universe. We often wonder why we exist, why there are planets and stars, and what other possible destinies might have been. These are age-old questions that have prompted philosophers, scientists, and theologians to seek answers throughout history. Our understanding of the universe has evolved, but many of these profound questions remain unanswered. Are we simply a product of random cosmic events, or is there a deeper purpose behind our existence? These questions challenge our perspective on life and the universe, prompting humanity to explore the unknown, not just to understand the cosmos but to understand ourselves in the context of the universe. It's common for us to ignore problems until they become critical, even when we know they will eventually affect us. This tendency is especially true in regard to environmental or astronomical phenomena. We often only address issues like climate change or space hazards when they directly threaten our well-being. The same could be said for the dangers posed by stars like Betelgeuse. Though we know that such massive celestial bodies could one day present a significant threat, we often take these threats for granted until they become undeniable. This procrastination in addressing problems often comes at a cost, forcing us to respond reactively rather than proactively. One such concern is Betelgeuse, one of the largest stars in the sky, which has begun to show alarming signs of instability. The star, part of the constellation Orion, is known for its remarkable size and unique characteristics. Over time, scientists have noticed unusual behavior from Betelgeuse, including pulsations and changes in brightness. These signs indicate that the star may be entering the later stages of its life. As one of the most studied red supergiants, Betelgeuse offers valuable insight into the life cycle of stars. However, its recent instability has scientists concerned, as it could signal an impending transformation with potentially catastrophic consequences for the star system. This star has been the subject of much study due to its enormous size. Betelgeuse's size is truly mind-boggling, being hundreds of times larger than our Sun. Its immense scale makes it an exceptional subject of study for astronomers, as it helps scientists understand how massive stars evolve. Compared to the Sun, which is considered an average-sized star, Betelgeuse is a true giant. It is one of the largest known stars in the Milky Way, with a radius so vast that, if it were placed at the center of our solar system, it would extend beyond the orbit of Jupiter. This size is both impressive and a source of concern, as it makes the star unstable. In fact, Betelgeuse is so large that it makes our Sun appear tiny in comparison. The size disparity between these two stars is a testament to the vast range of star sizes that exist within the universe. While the Sun is classified as a medium-sized star, Betelgeuse falls into the category of red supergiants, which are some of the most massive and volatile stars in existence. Betelgeuse's enormous size means it has a short lifespan compared to smaller stars, burning through its fuel at a much faster rate. Eventually, this will lead to the star's collapse and subsequent explosion, a supernova that will end its life in a spectacular and violent event. Unlike other stars, Betelgeuse is a red supergiant, located more than 640 light-years away from Earth. Though this distance may seem vast, in cosmic terms, it is relatively close, making Betelgeuse a prime subject for observation. Red supergiants like Betelgeuse are in the final stages of their stellar evolution, and their instability provides clues about the fate of stars much larger than our Sun. The size and distance of Betelgeuse make it an extraordinary object of study, allowing scientists to observe the behavior of massive stars as they reach the end of their lives. Understanding Betelgeuse helps astronomers piece together the puzzle of stellar evolution and the ultimate fate of the universe's largest stars. While this distance may not seem significant at first, in cosmic terms it is vast. The sheer scale of the cosmos is difficult to comprehend, and even the closest stars are far beyond our reach with current technology. To put things into perspective, 640 light-years means that light, the fastest thing in the universe, would take over 6 centuries to travel from Betelgeuse to Earth. This immense distance is a reminder of the vastness of space and the challenges that come with studying such distant objects. Despite this, Betelgeuse's relative proximity makes it a valuable subject for researchers, as it offers insights into the behavior of stars at the end of their lives. Even if we could travel at the speed of light, it would take over 640 years to reach it, something impossible with our current technology. The limitations of human space travel are stark when compared to the sheer size of the universe. Even at light speed, which is the fastest known speed, the time it would take to reach Betelgeuse illustrates the immense distances that separate stars and galaxies. With current space exploration technology, traveling to even the nearest stars remains an unattainable goal. However, our advancements in astronomy and astrophysics allow us to study these distant stars without physically reaching them, providing valuable knowledge about the universe. Under normal conditions, such a journey would take us more than 12 million years, which is longer than the entire history of humankind. This puts into perspective how small and fleeting human existence is compared to the vast timescales of the universe. The idea of traveling across such distances is almost inconceivable when you consider how long it would take to get there. Our human lifespans are insignificant compared to the lifespan of stars, and the time it would take to reach even the nearest celestial bodies highlights our current limitations in exploring the cosmos. These time scales reinforce the awe-inspiring scale of the universe and our place within it. This immense distance gives us a sense of the star's size and power, and recently, Betelgeuse has been trembling intensely, which could indicate something unsettling. Betelgeuse's fluctuations in brightness and instability signal that it may be nearing the end of its life. The recent tremors in the star suggest that something extraordinary is occurring within it. For decades, astronomers have been closely monitoring Betelgeuse because its massive size makes it an interesting subject for studying the final stages of a star's life. Its trembling could be a precursor to an event that will radically alter the surrounding space, possibly culminating in a supernova explosion that will end its existence. Despite their quiet appearance, stars are far from still, no matter their size. While we may view them as calm and stable points of light in the sky, stars like Betelgeuse are far more dynamic than they seem. The life cycle of stars is a constant process of birth, growth, instability, and death. Even stars that appear steady are in a constant state of change, their internal processes constantly shifting. Betelgeuse's pulsations and the changes in its brightness demonstrate that even the most stable-seeming stars are subject to powerful forces within them. These changes provide critical insights into the processes that govern stars and their eventual demise. Betelgeuse, for instance, has long been known as a pulsating red supergiant, with its brightness fluctuating in cycles that range from 10 to 100 days, depending on whether the star is expanding or contracting. These pulsations are a natural part of the star's behavior, as it transitions through different stages of its life cycle. The changes in brightness reflect the dynamic processes within the star, including the fusion of elements and the shifting of its outer layers. Betelgeuse's pulsations offer a unique opportunity for scientists to study the inner workings of a massive star as it nears the end of its life. These gradual changes illustrate how dynamic the star is. The way Betelgeuse fluctuates in brightness shows that it is anything but static. This behavior is characteristic of red supergiants, which are undergoing significant changes as